Good day to all of you. I am Sivaram, former senior executive with 47 years of experience from SSI Paper and Boards Limited, E-Road. I am very glad to meet you all once again. In our last episode, we have seen the video on the first part of TPM. That is, what is TPM, who introduced TPM, and when TPM was introduced, and why we need TPM. Also, we have seen what is OEE, that is overall equipment effectiveness. In continuation, we will be discussing about TPM part 2 in this video. I have simplified TPM to suit our Indian work culture for better understanding and for easy implementation. Since TPM is a very big subject, I have divided this tool into 7 parts and prepared in a simple way that even a layman can understand and with examples and data. This free video can be used as learning and teaching material. Let's move into the subject. This is the roadmap, steps and activities to be carried out for implementing TPM. Part 1 highlights what is TPM, how to calculate OEE percentage. Part 2 speaks about TPM main pillar autonomous maintenance. Part 3 is step 1A, how to perform initial cleaning with meaning. Part 4 is about step 1B, that is abnormality identification, white and red tags. And step 2, how to eliminate abnormalities, sources of contamination and inaccessible places. And step 3, how to establish tentative standards for cleaning, inspection and lubrication and retightening. In part 5, we will discuss about CILT methodology. In part 6, we will discuss how to kickstart TPM in a structured way. In last part 7, we will know about equipment ownership card, abnormality register and minutes and photo gallery on recognition and reward. Welcome to TPM training part 2. In this video, we will be discussing about overall equipment effectiveness and their losses. The 6 big losses which impede OEE percentage. What are these 8 TPM pillars? TPM heads and pillar chairman. Significance of the TPM pillars. Let's move into the subject and see what are the big losses which impede OEE. In the last video, we have seen how to measure and calculate OEE percentage, that is availability percentage, performance percentage and quality percentage in the production machine are together multiplied to arrive at OEE percentage of the particular production machine. Ideal OEE as per TPM should be 85% plus. Let's see what will be the OEE of your machine. You will be surprised to see the OEE value of the production machine in your company. It works out to be around 50 to 60% only. There is much scope for improvement. You want to know the reasons, what are the factors which are causing you to get such a low OEE percentage. TPM has identified 6 big losses which impede OEE percentage. There are 6 big losses against availability, performance and quality. Now let's see what are the big losses which affect the OEE of the equipment. These 6 losses are obstacles to achieve equipment effectiveness. These losses are often neglected by the operator since they think that these are insignificant and not tracked properly even by the management. These losses, when grouped together, will lead to significant reduction in availability, production, quality and affect the OEE percentage. Hence, TPM considers them as the main big losses which are to be measured, accounted properly, RCA, that is root cause analysis, to be done and necessary corrective actions to be taken to set right the causes to improve OEE percentage. Let's see what are the availability losses, which is divided into 2 types of losses. They are equipment failures, that is losses during unplanned stoppages, and setup and adjustment losses, that is losses due to planned stoppages. Performance loss is further broken down into 2 losses. They are idling and minor stoppages, that is losses due to small stoppages in the machine. Reduced speed in the machine is is running at slow speed. As a result, production is also reduced. Quality loss is divided into production defects, that is, they are defects not conforming to specification, hence totally rejected. Startup defects is that defects can be recycled or reworked to required specification and can be reused for, but resulting in waste in energy and cost. Now let's see the big losses in detail. First, against availability loss. First loss is equipment failures. These are unplanned stoppages due to unexpected equipment failures. Examples are due to unexpected equipment breakdowns, unplanned maintenance, inconsistent supply of input material from upstream process, or output being blocked by the downstream process problem. Reasons are improper maintenance, poor planning, mistakes by operator with a low skill due to poor training, CILT activities, that is cleaning, inspection, lubrication and tightening, not followed strictly, sometimes due to machine wear and tear, and electricity failures. Second loss is setup and adjustment losses. These are planned stoppages to attend to planned events. Examples include changeovers due to quality change, excess startup adjustments, tooling adjustments, cleaning time, warm-up time, planned maintenance. Reasons are insufficient skill for quick adjustment, poor planning, want of appropriate tools, insufficient support from others. Let's see the losses against performance losses. Third loss is idling and minor stoppages. These are small stoppages. Examples when equipment stops for a short period of time, typically a minute or two, and is resolved by the operator himself without the help of maintenance personnel. Small stops are often chronic. Same problem repeated on the same day or on different days. Machine getting jammed, etc. These stoppages are also not measured and accounted properly. Reasons: actor, operator running machine with incorrect settings, operator absence means he stops the machine for a short time to attend to some other work, misalignment or blocked sensors, periodic quick cleaning, waiting for material, temporary process problem. Fourth loss is reduced speed. That is, equipment runs slower than the design speed, resulting in lower throughput. Reasons: mechanical problem, dirty or worn out equipment, poor housekeeping and maintenance, that is poor lubrication, incorrect setting, substandard quality and inconsistent input material, poor environment condition like temperature, humidity and lighting, poorly trained and inexperienced operator. Fifth loss, that is production defects. They are defective products produced during the stable production. Example includes products that are rejected and defective products that cannot be reworked since they do not meet the quality specifications. Reasons are due to incorrect equipment settings, operator negligence or low skill level, inferior quality of inputs, change in temperature and pressure, inconsistent material, poor calibration, misleading instruments, SOP, that is standard operating procedure, and quality process parameters not followed. The final sixth loss, startup defects. These are defective parts produced from startup until stable production is reached. They can be reprocessed into quality products by recycling or reworking. They can occur after any equipment startup or warm-up time. Commonly happens after changeover from one quality to another quality. Reasons are doing minor adjustment after changeovers, not following startup checklist in SOP. Now, how to address these big losses, 6 big losses? First, measure and quantify all these losses, give priority, do RCA and find out the root causes and take necessary corrective action to eliminate the root causes for improving the OEE percentage of the machine. Now we come to the TPM pillar. Let's see what are the pillars in TPM and their significance. There are 8 TPM pillars. The first and important pillar is autonomous maintenance, second is focused improvement, third is planned maintenance, fourth is quality maintenance, fifth is education and training, sixth is development management, seventh is SHE, that is safety, health and environment, and the last 8 is office TPM. You can see that 5 years is the foundation of TPM. Let's see the roles and responsibilities of top executives in the TPM company. First, there must be a head for TPM. Normally, the top executive will be head, example MD, managing director. We need to nominate separate chairman for each pillar also. Here is a sample list of TPM pillar chairmen. Senior executives will be in charge of each pillars. Example, for autonomous maintenance pillar, the head of production will be the chairman. For focused improvement pillar, works manager will be the charge. For planned maintenance, head of maintenance will be in charge. And quality maintenance, head of lab and QAD, quality assurance department will be the chairman. For education and training, head HRD will be the chairman. For development management, head project, and for head and safety environment will be in charge, and for office TPM, head commercial will be in charge. Now let's see what are the significance of these pillar chairmen. HODs will seek the help of these chairmen only to such problems which they cannot solve themselves in their department, and they need expert external advice and help. Each pillar chairman will be assisted with a team comprising of cross-functional members to help in visiting and studying the problems at the respective sites, interact with shop floor personnel, study with their present and past problems, collect relevant data, analyze them, do RCA, and suggest corrective actions to be taken for solving these problems. If need be, pillar chairman concerned to arrange necessary resources to solve the HOD's problem. Now let's focus on the first TPM pillar. In TPM, very much importance is given to the first TPM pillar, that is autonomous maintenance. By understanding well and practicing autonomous maintenance sincerely, you can see significant improvements in your company. Let's see what autonomous maintenance is all about. Topmost is much importance is given for teamwork. Autonomous maintenance brings production and maintenance people together, that is process to work as a team with mechanical, electrical, instruments, civil personnel to accomplish a common goal, that is to stabilize equipment to its ideal conditions, improving the overall performance and reliability of equipment, and thus avoid accelerated deterioration of the equipment. Next important point is know your equipment. It is designed to help operators learn holistically about the equipment thoroughly, how the equipment functions in the process, what common problems can occur, why they occur, how these problems can be prevented by early detection and treatment of abnormal conditions in time. What will be the impact to the next process if the ownership equipment fails or creates quality defects. Next is maintenance of equipment basic condition. It means that bringing back the present state of the machine to its original condition when it was new. This is achieved by the ability to detect, correct and prevent equipment abnormalities. Make improvements by implementing planned and periodic maintenance and process cleaning schedules essentially, restoring back the removed parts in the machine. Autonomous equipment maintenance. Give practical floor training to the equipment owners so that they can do small maintenance jobs by themselves safely using appropriate tools. Skilled maintenance personnel will be used effectively to spend on more value-added activities and technical repairs. Develop and use autonomous maintenance checklist, that is CILT check sheet for cleaning, inspection, lubrication and retightening of loose parts. Standardize the frequency of doing CILT, tools to be used, lubrication grade to be used, and how to reduce the time for doing CILT activities. Against quality and quantity, operators should be thought the relationship between equipment and quality and production. They should know the critical parts in the equipment which may affect quality and quantity of the product, and they should mark clearly the areas in the equipment sketch where quality or production problem can occur. They should also be trained to know what are the causes and how to eliminate quality defects and loss of production. Teach them how to do RCA, root cause analysis, and take corrective steps to rectify the causes permanently. Lastly is safety. Most important thing is that operators should be fully aware of the safety points in the equipment and its area. Example, safety guards in place, worn out platforms, handrails, damaged motor earthings, worn out steps, etc. to use appropriate PPEs without fail. Also ensure no unsafe places or no unsafe acts in the workplaces. Understand the cause of accidents and take corrective steps to ensure they do not occur. The second pillar is focused improvement. Let's see what it is. This pillar focuses on how to enhance OE, overall equipment effectiveness. Focus improvement is an activity by a cross-functional group comprising a process, mechanical, electrical, instrument project, focusing on specific problem faced in a department. Focus improvement aims at maximizing the overall effectiveness of the equipment, processes, and plant through elimination of all losses and improvement in performance. It also helps problem solving. As people get bogged up in routine activities and problems, there is no focus on solving different problems. As a result, loss and waste continue to build up. A multifunctional focus improvement circle helps to study, do RC, and solve the problems. The improvement should prepare in the following ways. Visit the spot and interacts with the working team at the shop floor. Understand fully the problem and the losses. Observe the workplace minutely to discover what is actually happening. Gather data of failures, defects, and other losses and plot these over time. Do RCA and find out the root cause for the losses and take necessary corrective action to eliminate the causes. Helps the department to establish basic equipment condition to improve the OEE percentage. The third pillar is planned maintenance. Planned maintenance is a specialized maintenance carried out by the maintenance department to avoid deterioration of the machine. It is aimed to have trouble-free machines producing defect-free products for total customer satisfaction. It focuses on how to improve the equipment life cycle and also improvement in a planned maintenance program. An efficient planned maintenance program combines time-based maintenance or preventive maintenance. That is, maintenance performed on equipment based on a calendar schedule which is prepared in advance and strictly adhered to. Condition-based maintenance. What is condition-based maintenance? Maintenance performed when certain indicators show signs of decreasing performance or upcoming failure. Then we come to breakdown maintenance. Breakdown maintenance performed on an equipment that is broken down or otherwise cannot be operated at all. The goals of planned maintenance are to eliminate equipment failures, process problems, minimize losses, and ensure safety. Understand the situation. Measure and quantify the following: frequency and severity of repeated failures and minor stoppages. MTBF, that is mean time between failures. MTTR, that is mean time to repair. Maintenance costs, breakdown maintenance rates, etc. Establish basic conditions, reverse deterioration, and abolish environments causing accelerated deterioration due to external contamination, etc. Coordinating with the autonomous maintenance team, introduce improvements to reduce the repeated process failures. The fourth pillar is quality maintenance. Quality maintenance objective is aimed towards customer delight, producing highest quality through defect-free manufacturing. It consists of activities that establish equipment and process conditions that do not produce quality defects, with the goal of maintaining equipment in perfect condition for producing quality products. Quality defects are prevented by checking the process parameters and measuring equipment conditions periodically and verifying that the measured values lie within the specified range. Potential quality defects are predicted by measuring, monitoring, and in-process parameters upstream and preventing them by taking necessary corrective action in advance. A quality maintenance program is strengthened by the gains achieved through fundamental TPM activities such as autonomous maintenance, focus improvement, planned maintenance, and providing shop floor skill training to both process and maintenance personnel. Elimination of accelerated deterioration, elimination of process problems, and development of competent operators are prerequisites for the successful quality maintenance program. Fifth pillar is education and training. Education and training pillar prepares education and training systems designed to maximize potential of employees. Breakdowns are the root cause of all problems because when they occur, production stops, deliveries are delayed, and product defects are created. In other words, a single breakdown can wreak havoc throughout the factory and can break down the entire operation. Whenever you look deeply enough into the reasons for any breakdown, you always find people related causes. These people should be trained well how to identify abnormalities early in the equipment and take immediate corrections to avoid costly breakdowns and quality defects. Education and training calendar is made to systematically give both classroom, theoretical and practical training on the shop floor so that equipment competent skill operators and equipment competent skill maintenance personnel are developed. These personnel are given training on how to identify problems beforehand to avoid breakdown, how to reduce quality defects, how to reduce costs, how to work safely, how to avoid pollution, how to reduce waste, and what is safety clean and what is not safety clean, how and what to inspect, lubricate with correct grade, how to retighten loose parts, eliminate source of contamination, and set right inaccessible places for doing CILT, that is cleaning, inspection, lubricating, and tightening. The sixth pillar is the development management. Development management is a procedure to critically review an equipment or process at design stage itself so as to improve the equipment's life cycle and develop maintenance-free equipment. Optimizing life cycle costs, trouble-free plant maintenance after construction, maintenance prevention, and trouble-free process performance that is easy to use assures quality product are achieved by development management practices. Life cycle cost of an equipment or system is its total cost during the whole of its life. It is a sum of direct, indirect, recurring, and other related costs during the design, development, construction, operation, and maintenance. In other words, to ensure maximum return on investment of the new or modified machine. Let's see how the team works. Maintenance prevention design activity minimizes future maintenance costs and deterioration losses of new equipment by taking into account maintenance data on current equipment and the new technology. Then design the equipment for high reliability, maintainability, operability, and safety. We come to the seventh pillar, that is SHE, that is safety, health, and environment. Safety, health, and environment has procedures focused on equipment, processes, and people towards achieving zero accident, zero health hazards, and zero pollution. To eliminate accidents and pollution, employees are made safety conscious using PPEs. Equipments are checked periodically and attended to eliminate safety hazards and correcting the pollution area, creating areas. As part of initial cleaning, detect and correct any problems that might affect safety, health, or the environment. Sources of contamination are the threat to safety, pollution, and equipment's deterioration. Eliminate sources of contamination and work towards achieving zero leak. First, stop all leakages, whether it's a water leak, steam leak, chemical, or condensate leak. Include safety procedures in cleaning and inspection standards. Develop equipment and process competent people. The more people know of the equipment and processes, the more safety they can work. Link safety education with case studies during the training programs. Safety officers to ensure there are no unsafe places, no unsafe acts, no leakages, no spillages noticed during their daily walkthrough inspections. Ensure that everyone is confident and knowledgeable about safety. Now we come to the last pillar, that is the eighth pillar is Office TPM. Office TPM focus on improving office functional efficiency and eliminate all wastages and losses in all the administration departments like purchase, stores, HRD, accounts, marketing, etc. The Office TPM is oriented to provide excellent support for both process and maintenance activities inside the factory. Educate and give training on how to do cleaning with meaning and purpose. Eliminate source of dirt, dust and trash in the office, storerooms, etc. Eliminate unwanted and unneeded items. Remove any obstruction to movement with ease in the office. Rearrange furniture and office equipment to get better office space. Make hard to inspect places more accessible for easy cleaning and inspection. Ensure there are no rodent or insect menace in the office and pantry area. Prepare business process manual with objectives and targets. Eliminate activities that do not add value to your business. Formulate effective filing system with labels indexed with a neat arrangement. Ensure retrieval time for file is within 15 seconds. Look for losses. Cost reduction is in consumables, inventory, communication, transportation, etc. Reduction in processing and lead time. Enhance visual management. Locations are important things clearly designated to save time in searching. Ensure that there are no potential safety hazards in the office. All electric fittings should be intact and cables well dressed. Ensure sufficient number of fire extinguishers available. Train people how to operate them in case of emergency. Ensure personal computers and photocopiers are maintained well. Ensure equipment ownership is allocated to important equipment. We have come to the concluding part of this TPM part 2. My next video will be on TPM part 3, where we will discuss about the TPM step 0, that is know your equipment, and also about TPM file, how to prepare this file. Step 1, part A, which highlights how to perform initial cleaning with meaning and purpose. Thank you all for your patience hearing. If you like to review my previous videos of my profile and my 47 years of journey through Sashashai Paper and Boards Limited and my subsequent videos on 5 years concepts, please search Learning with Sivaram in YouTube and click the icon Plant in Folded Hands. I repeat, click the icon Plant in Folded Hands so that videos can be viewed in sequence. If you like these videos, please don't forget to press the like image and also click and subscribe and bell icon and share among your friends. MSMEs, entrepreneurs, factory employees, college students will also be benefited. I require the information to assess how many people have gone through these videos and like them so that I can move forward and prepare further free videos on management systems, tools, etc. How to become a green company, root cause analysis, Kaizen, risk management, etc. for knowledge sharing. Once again, thank you all. Have a nice day.